What up? It's going to be a very short lecture on active transport. Remember that active transport is transport that actually requires energy. So what you're doing is you're going up, or you can say you're going against the concentration gradient. So at the bottom of your paper, you should see a blank box. If you would, please draw that hill once again, and draw a high and a low. And then I'd like you to draw an arrow that goes up the hill. Okay, so obviously if anything's going to go up the hill, it's going to need a little help. It's not going to go by itself. So what's going to help it? Energy. Energy is going to be needed to make it go up that hill. All right. So in this case, remember that we're going against the concentration gradient, meaning that molecules are going to be moving from a low to a high concentration, as opposed to in passive transport where they're always going from a high to a low concentration, low to high. Okay, so an example is the sodium-potassium pump, and it has to do with sodium and potassium. I'm not going to go into details. If you're interested, you may look in your book. They give a lengthy explanation about the sodium-potassium pump. You should have already read that in your reading assignment, but that's just probably the most famous example of an active transport. All right, so usually active transport is helped by the use of those membrane proteins that are in that lipid bilayer, or little tiny vesicles that are actually made of lipid membranes. And vesicles are basically just kind of little tiny, they almost look like bubbles or little sacs, right, that are made of the lipid bilayer, all right, which means that they can kind of attach to the edge of the cell membrane, and you'll understand why this is important in a little bit. So remember, it could be actively transported by the membrane proteins or vesicles. So we're going to focus on the actual vesicles and how they actually actively transport things in or out of the cell. Okay, and usually you're going to use vesicles when you have molecules that are much too large to actually diffuse right through the lipid bilayer, or are too big to even go through the membrane proteins that are available. Okay, so with vesicles there are two ways. Transportation inside the cell, or transportation outside of the cell. So if a substance is being transported in the cell using a vesicle, we call that endocytosis. And if a substance is being transported out of the cell with the vesicle, it's called exocytosis. Easiest way to remember this is exo kind of sounds like exit. Things are exiting when they're leaving the cell. Okay, so this last slide is just giving you a diagram of endo versus exo, and you can see right here, this right here is a vesicle. Here's another vesicle, and you can see this peachy kind of skin colored is actually a phospholipid bilayer. You can see the heads of the phospholipids and the tails that are in there. It's the same makeup as the cell membrane. Okay, so when you have endocytosis, whatever this substance is, it's going to be in a much lower concentration. Here, it wants to get inside the cell, and even though the substance isn't diagrammed right here, it is in a lower concentration. So what ends up happening is the cell membrane will actually form the vesicle itself. It'll start kind of caving in, all right, and the substance will flow into that caved-in portion of the cell membrane, and then the cell membrane will start to pinch off with the substance enclosed inside of it and detach itself from the cell membrane. You've got the vesicle there. The vesicle can then transport that substance wherever it's needed within the cell. Okay, endocytosis. Exocytosis is just the opposite. You have a vesicle that's made of the lipid membrane. It has a substance inside of it. It's in a low concentration inside the cell. It will be at a higher concentration outside of the cell, so we're going against the concentration gradient. The vesicle travels toward the cell membrane. It almost attaches and kind of becomes part of the cell membrane, and as you can see, it basically just kind of pushes that substance out. Exocytosis. Alright, it's very simple. That's as detailed as we're going into. That's the end of this one.